So good evening dear students. So welcome to Maths EAPCET crash course. Now we will be discussing the chapter of matrices and determinants. Okay. In the previous class we concluded with what? Probability. Okay. And we have already discussed what is dearrangement, and also we have done the previous year questions pertaining to probability. Now we will be starting with matrices and determinants. If you talk about matrices and determinants, the weightage that you are getting be it for AP or for TS, what is the weightage if you ask me? You are getting an average 3 to 4 questions. An average 3 to 4 questions. Out of these 3 to 4 questions, all the questions are what? Doable and also easy to moderate. They are not difficult. Okay. Some questions may be what? Calculative or lengthy, but they are easy to moderate. They are easy to moderate. And why it is easy to moderate? Because you should definitely have the knowledge of your IPE. What you studied for your board exams, the knowledge of matrices and determinants, that is definitely useful here, but you have to know certain tricks. Okay, there you used to write all the steps that is required. Here you will not be writing all the steps. We will be using certain tricks and also certain important results, so that you get the answer very quickly. Okay, clear? So let us get started with what is matrices and determinants. So if we talk about matrix, okay, this is A. We can represent it as an ordered pair of A of ij. Ordered pair of A of ij, or matrices can also be written as C here. A of ij can be written as C. For example, I can write it as A, B, C, D. Okay. So here this whatever is horizontal, this one, this line, this horizontal, we call it as what? Rows. This vertical we call it as what? Column. So how many rows are there? 2 rows. We will write rows here. How many columns are there? 2. So 2 cross 2. 2 cross 2. In differential equation we studied about order. Same thing here also in matrices we will have what? Order of a matrix. This 2 cross 2 is called as what? Order of the matrix. Okay, order of the matrix. Order of the matrix. Then this can also be represented as M cross N. We usually represent it as M cross N. Okay. So here the order is what? 2 cross 2. Sometimes we will say that we need a matrix of even order, odd order. That time M cross N should be what? M and N. M should be odd and N should be odd. That is known as even order or odd order. It is not M cross N should be odd. That is the multiplication, the product is not. It should be M should be odd and also N should be odd. That is known as odd order. And M and N each are even means we call it as even order. It is not the product. Each of the elements should be 1. What is it? Even. That is number of rows should be even and number of columns should be even. Number of rows should be odd and number of columns should be odd. Now if I represent this as another example, if I take, suppose I take 3 rows like this and 3 columns like this. Okay, I will write it as how many? This is first row, first column, this is first row, second column, first row, third column. This is second row, first column, second row, second column, second row, third column. This is third row, first column, third row, second column, third row, third column. This each of this, suppose I take this element, this A12 is an element, this 12 is representing the place of this element. This place of this element I can also call it as the address of this element, you can take, or the location of this element in this matrix. The location of the element in this matrix we call it as what? A12. The location of the element in this matrix is what? A12. Okay, A12. Clear? So these are the basics you must know when it comes to what is a matrix. This A12, if I say, you should know it is what? It is first row, second column. If I say A31, it is what? Third row, first, what is it? Third row, first column. These are the basics you must be knowing when it comes to what is a matrix. Next, order of a matrix I told you. See, a matrix if they give like this, order can be odd or even. See, if I talk about a square matrix, what happens is, order when we talk about square matrix, M will be equal to N. M will be equal to N. Okay, M will be equal to N means I can take it as what? Order will be, I can take it as 3 cross 3, 2 cross 2, okay, 4 cross 4. Okay, that is known as M will be equal to N, square matrix. But when it comes to rectangle matrix, M will not be equal to N. Rows will be not equal to columns. Okay, that is known as what? Order. See, this is called order, but if they ask odd order, it is, this is odd order, this is even order, and 5 cross 5, that is odd order, like that. That is the meaning of order of the matrix. That is the meaning of order of the matrix. Very important. If you know what is the order of the matrix. Clear? Next, because suppose when we say multiplication of the matrix, that time order of the matrix matters a lot, because I will tell you when I talk about multiplication, M cross N matrix is there given. Okay, then you can multiply with another this one. Okay, another matrix, it should be a what? N cross D something, whatever it is. That is, this first row, this first matrix, the columns should be equal with the second matrix rows. First matrix, the columns, number of columns here it is 3 means here the number of rows should be 3. Okay, that is here this one and this one will get cancelled, and the product matrix what we will get will be of the order M cross D, M cross D. So whenever matrix multiplication, you know the basics already, when it comes to matrix multiplication, what happens is the number of columns of the first matrix should be equal to the number of rows of the second matrix. Correct na? Understanding? Srinidhi, Vaishnavi, Liharika, Akshaya, getting it? Harsha, Sharan, focusing, right? So when you talk about multiplication, order matters even more. What happens? The columns of the first matrix should be equal to the rows of the second matrix. Okay, this is when it comes to order of the matrix. Good evening. Okay, fine. Okay, let us continue. Types of matrix, let us understand. What is the meaning of types of matrix? Various types of matrices will be there. So if I say row matrix means it is a matrix where it is having only one row. Okay, for example, I can take it like this. There will be only one row. This can be 0, 1, 2, 3, 4, 5. Here row matrix means the order of the matrix will be 1 cross M. That is row, number of rows. First what we write is what? Rows. Oh, 1 cross M. This M can be anything. Here this is columns. Here M is what? 6. But the number of rows is what? 1. That is row matrix. This, if I write horizontally like this, this is known as what? Where the number of columns can be anything. But here it is what? Row matrix. This is called row matrix. What is column matrix? Where the number of columns is just 1. 0, 1, 2, 3. If I write it like this, this is what I can write it as how many, this is what, how many rows are there? 1, 2, 3, 4. 5 cross 1 or M cross 1. Here the number of columns should be 1. Here the number of columns should be n. Okay, if I write an example, if I write a matrix like this, is it a row matrix or a column matrix? It can be both. If I write like this, it is both row matrix and also column matrix. Got it now? If they give it like this, a matrix A represents row matrix and also column matrix, they can give a question. That time you should take the example like this. It is both row matrix and also column matrix. There is only one row and there is only one column, because they can ask a question like this. Okay, but here it is what? This is just a row matrix and this is just a column matrix. Clear? Next one. Null matrix or zero matrix. What is this? Null matrix or zero matrix? See, if this is represented by O, all the elements A of I11, A of 12, A of 13, all the elements, okay, each of the element in this matrix is what? 0. Okay, this can be of any order. The matrix entries are zeros. What about this? If I write like this, this is also a null matrix, or also it is also called as zero matrix. Okay, null matrix or zero matrix, this is what? 0. All the elements are 0, not the diagonal elements. What is diagonal elements? I will tell you. So this is what? All the elements are 0. This is zero matrix. Next, rectangular matrix, square matrix. Rectangular matrix means it is a matrix where M is not equal to N, where the number of rows is not equal to number of columns. There is no remote. Okay. Where the number of rows is not equal to number of columns. Okay, thank you. So see here, I can write it like this. So see here, how many rows are there? 3 rows. How many columns are there? 4. So this is what? Rectangular matrix. That is M cross N we write it. Okay, but M is not equal to N. This is rectangular matrix. And square matrix, highly important. 99% of the questions which we solve will come from what? Square matrix only. Okay, we will be solving from square matrix. So this is, if you take it, here M cross N, this is a matrix of M cross N, then M should be equal to N. That matrix is called as what? Square matrix. This can be what? 1, 2, 3, 4, 5, 6, 7, 8, 9. So here number of rows is not equal to number of columns. This is what? 3 cross 3, odd order. If I write like this, 1, 2, 3, 4, 5, 6, This is what, this is also a square matrix of even order 2 cross 2. So, this is a square matrix. Now, whatever types of matrix I am going to talk about from now, they will be a square matrix. I am talking with respect to what? A square matrix. Okay. Most of the things what I will be talking now will be based on what is a square matrix. Clear? Now, see here, diagonal matrix. This is the same when it comes to what? Diagonal elements are upper triangular elements, all these things are there. But before going to diagonal matrix, I will talk about diagonal elements. I will talk about diagonal elements. Now, see here, suppose this is the matrix. Okay. So, let us take it as A, B, C, D, E, F, D, E, F, okay, G, H, I. This is a matrix, let this be A is equal to. Okay. So, from left top corner to right bottom corner, the elements that we have, these elements are called as, not diagonal, I am not talking about diagonal matrix, I am talking about diagonal elements. These are what? Diagonal elements. These are diagonal elements. I am not talking about diagonal matrix, this is diagonal elements. Diagonal elements, these are diagonal elements. These are diagonal elements. Then, if I talk about these things, these, okay, they are called as what? Lower triangular elements, not matrix, lower triangular elements, lower triangular elements, lower triangular elements. When I say next time, when we solve the question, so lower triangular elements, if they are given like this, if I say these are the things you have to consider. Upper triangular elements, these are upper triangular elements, upper triangular elements. Please make a note, because when I say in next time in a question, you should not get confused. What is upper triangular elements, what is lower triangular elements, you should definitely be able to recognize. Clear? Okay. Now, I told you about what? Elements, diagonal elements, upper triangular elements and lower triangular elements. Now, let us go for diagonal matrix. These are the elements I am talking about. Whenever I say diagonal elements, these are the elements you should consider. Now, we will go for what is a diagonal matrix. So, when we see what is a diagonal matrix, see here, if I consider 3 cross 3 matrix, let this be A, B, C, D, E, F, same thing, G, H, I. Okay. Here this matrix A is there. This is of what? 3 cross 3. I will write it as what? Instead of 3 cross, okay, let me write it as 3 cross 3. So, A can be written as A is equal to A of Ij, where okay, it is called a diagonal matrix, where I is not equal to j, A of ij is equal to 0 for I is not equal to j, for I is not equal to j. This is how I will write it, for I is not equal to j, for I is not equal to j. So, instead of this, let me write it like this, instead of this, let me write it like this, A11, A12, A13, A21, A22, A23, A31, A32, A33. Now, tell me what is this I is not equal to j. Now, tell me what is a diagonal matrix. Think, A of ij, A is equal to A of ij, where A of ij is equal to 0 for I not equal to j. So, listen, I not equal to j means I is what? It is representing number of rows, j is representing number of columns, wherever the number of rows is not equal to number of columns. So, here it is equal, no? Here it is equal, here it is equal, but here and this here, this one, this one, this one, this one, this one, this one, it is not equal. There the element should be what? 0. Okay. Diagonal matrix is a matrix except the diagonal elements, all the other things are 0. Except for diagonal elements, all the other elements are what? 0. So, A I should write it as what? I should write it like this. Okay, A11, A22, A33, 0, 0 and 0. Here 0. Okay, and what happens? 0 and 0. Correct, na? This is what we will have. So diagonal matrix means it is a matrix only only the diagonal elements are there. All the other elements are 0. All the other elements except diagonal elements are 0. Okay, mandatory it is what? Except diagonal elements, all the other elements should be 0. Should be 0. So example I can give like this. See here, this is a diagonal matrix. This is a diagonal matrix, correct na? This is a diagonal matrix. See, all the other elements are 0 except for diagonal elements. Now my question is, if I write like this, is this a diagonal matrix or not? Is this a diagonal matrix or not? This is also diagonal matrix. Please listen, I told you except diagonal elements, all the other elements should be 0. I did not say that diagonal elements should not be 0, I did not say. I did not say. The main condition is except diagonal elements, all the other elements should be 0. The diagonal elements can be anything. The diagonal elements can be 0, 1, 2, 3, anything it can be. So see here, look at this. This one is coming out to be 0, 0, 0. But what about this one? This condition what I told you. A of ij should be equal to 0 for I not equal to j. I not equal to j, I not equal to j, I not equal to j. But there it is 0 only. But what about this? This can be anything. So you diagonal elements, only diagonal elements should be there, except that all the other elements should be 0. Even if diagonal elements are 0, it is fine. But all the other elements should be 0. But all the other elements should be what? Should be equal to 0. Understood? So here you took the example. See, all the other elements are 0. Here only diagonal elements are there. Such a matrix is called diagonal matrix. Suppose I write 0 here also. That is also diagonal matrix because all the other elements except diagonal elements are 0. This should be 0. This should be 0. This can be anything. It can take any value. It can be 0, minus 1, minus 3. It can be any value. It can be any constant also. Okay. So this is what? Diagonal matrix. Suppose now if I take here k 0 0 k 0 0 0 k. This is what? Is it a diagonal matrix or not? Yes, it is a diagonal matrix. Clear till here? You can make note of it if you want for your reference. What is diagonal matrix? Now see, now we will see a scalar matrix. A scalar matrix is a matrix where all the diagonal elements are multiplied by some scalar. That is the multiplied by scalar, or you can say that it is multiplied by some constant. So what we took example now. So k, 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 0, 0, 0, 0 and 0. So this is A if it is given. Here I can write it as what? A is equal to, I can write it as A of ij will be equal to what? A of ij will be equal to 0 for I not equal to j. But A of ij will be equal to what? Will be equal to k for I is equal to j. Whenever I is equal to j, 1, 1, 2, 2, 3, 3. This is 3 cross 3 matrix. So for this it is k. For other elements, for other where I is not equal to j, it is 0. If they give like this in the question, in the exam, it is nothing but what? It is nothing but a scalar matrix. You have to convert this. Just you have to understand I is equal to j means it is a diagonal matrix. Other elements where I is not equal to j, you have to put 0. Even if they give like this, you should be able to write, understand this is what? A diagonal matrix. Clear? Please make a note of this. This is important. Or instead of k, if I write this is what? 4, 4, 4, 0, 0, 0, okay, 0, 0 and 0. If I write like this, this is also what? A diagonal matrix, and it is also a scalar matrix. First of all, it should be a diagonal matrix, then only it can become a scalar matrix. Okay, this is a scalar matrix. Okay, here I can write what? A of ij is equal to j, 0 for I is not equal to j. For I is equal to j, A of ij is equal to what? A of ij is equal to what is the value for this one? 4. Okay, 4. If it is minus 1, minus 1, like that. Clear? Now, understand here only I will tell you what is scalar matrix or what is it scalar matrix is done, what is identity matrix or unit matrix if all the diagonal elements are equal. are equal and what is what? Equal to 1. All the diagonal elements are equal to 1 means, see 1 1 1 if it comes, that matrix is called as what? Identity matrix or unit matrix. Unit matrix. Identity matrix or unit matrix, and it is denoted by I. It is denoted by I. Okay, clear? So, first of all, a scalar matrix is one where all the diagonal elements are equal. Scalar matrix is one, all the diagonal elements are equal. But a scalar matrix, it is where a scalar matrix where all the diagonal elements are equal to 1. They are not just equal, but they are equal to 1. That is called as unit matrix or identity matrix. If I write like this, not like this. So 1 1 1. This can be 0 0 0. Not can be, it should be 0. Okay. This is what? Identity or unit matrix. We represent it as I. You must have seen A into I into A, like that. That is known as what? Identity or unit matrix. That is what I have written. Identity or unit matrix. Clear? So first is what? Square matrix. Then we studied identity matrix. Identity matrix is 1. Except for diagonal elements, all the elements are 0. But the diagonal elements can be anything. Need not be equal. All the elements of the diagonal elements need not be equal. It can be 1 2 3, anything like that. But if it is equal, it is called as scalar matrix. If it is equal and it is equal to 1, that is, it is called as what? Identity matrix. It is called as what? Identity matrix. That's it. Clear? Be Pusa, Akhil Pusa, that is good. Good morning. So clear? Understanding? Good morning they have told, we should also say good morning. We don't know from which country they are, no? There it might be morning. We should respect their geography and time also. Correct, na? So fine. Upper triangular matrix. Upper triangular matrix is a matrix where except for upper triangular elements, lower triangular elements are 0. Okay, that is known as what? Upper triangular matrix. Okay, so suppose upper triangular matrix. If I write like this can be A, B, C, this is D, E, F. Okay, these lower elements, lower triangular matrix elements are 0. So, see here, in upper triangular, lower triangular elements are 0. So, lower triangular elements are 0. Upper triangular matrix, lower triangular elements are 0. But when we talk about lower triangular matrix, upper triangular elements are 0. When we talk about upper, lower is not there, that is 0. When we talk about lower, upper is not there. Okay, so this will become what? I can write it like this. So, this will be A, B, C, okay, D, E, F, and this will be what? 0, 0 and 0. So, upper triangular elements are 0. That is known as what? Lower triangular. In upper, lower will be 0. In lower, upper will be 0. That's all. Clear? Understanding Bhavani, Akshaya, Harsha, Sharan, Vaishnavi? What is trace of a matrix? What happened? Diagonal elements. So, sum of the diagonal elements is called as what? Trace of a matrix. Let us take one question for that. So, when we talk about trace of a matrix, see here, let this be A1, B1, C1, A2, B2, C2, A3, B3 and C3. Let this be matrix A. Let this be matrix A. If they ask trace of A, it is nothing but sum of the diagonal elements. Here diagonal elements are what? A1 plus B1 plus A2 plus A1 plus B2 plus C3. This is known as what? Trace of a matrix. Now, if I give some example, if I ask trace of A, if the matrix is given as 1, 2, 3, 4, 5, 6, 7, 8, 9. What is trace of A? 15. This is matrix A. So, trace of A means we should do what? 1 plus 5 plus 9. That is what? 15. Understood? Sum of the diagonal elements. Sum of the diagonal elements is what? Trace of a matrix. If negative sign is there, that also should consider. 1 plus 5 plus minus 9 is there means 1 plus 5 minus 9. That is what? 6 minus 9, the answer will be minus 3. Okay, the answer will be minus 3 depending on the sign. That is known as trace of a matrix. Clear? So, based on trace of a matrix, we have certain properties. We have certain properties which you got to remember. Trace of a matrix, please write down. Okay, already it is there. See here. So, trace of a matrix, trace of A plus B is what? Trace of A, trace plus trace of B. So, A and B should be square matrices first of all. So trace of A plus B is trace of A plus B, A minus B is A minus B, trace of A is trace of A transpose. Trace of A will be equal to trace of A transpose. Why? I will tell you. Why? I will tell you. When I talk about transpose, you will understand. Trace of AB can be written as trace of BA. AB can be written as trace of BA. So this is one example. No need to worry about example. So leave it. So write down this. Write down this properties. Please write down this property. Please write down this property. Okay. Okay. This they are simple. Okay. Now equality of matrix, this is important. They have asked question from here. That is not exactly directly they have not asked equality of matrix. So this will come in one of the steps in the solution of some questions. That way we should know equality of matrix. Equality of matrix, two matrices are said to be equal. First of all, if their order should be equal. Suppose I write 2 cross 2, here also it should be 2 cross 2. Okay, if it is 2 cross 2 and this is 3 cross 2, never consider it as equal. Equality of matrix. If I write this as A, B, C, D, I will write this as 1, 2, 3, 4. What we call by equality of matrix means the corresponding elements will be equal. This will be equal to this B will be equal to 2, C will be equal to 3, and this will be equal to this. That is the address. The address of this is what? This one. So A will be equal to 1. So B will be equal to 2, C will be equal to 4, and D will be equal to, C will be equal to 3 and D will be equal to 4. First thing is what? Order should be equal, order should be same, and the corresponding elements will be equal. Corresponding elements will be equal. Okay. So this will be equal to this will be equal to this, like that. The corresponding elements, okay, will be equal. Corresponding elements, did you understand what is corresponding elements? Okay. Now, if I say now what is the value of A? Minus 1. What is the value of X? Y 2. Z is 3. That is known as corresponding elements, equality of matrices. Clear? Okay. From here we derive another concept, that is addition of matrix. Okay. Addition of matrix can be done only when their orders are equal, only when their orders are same. Okay. We can add them only when their orders are same. Equality of matrix does not mean that corresponding elements will be equal. Here equality of matrix means order should be same. Order should be same. Suppose matrix A is given as, we will take it as 1, 2, 3, 4, and matrix B is given as, okay, minus 1, 1, 3, minus 2. Okay, this is what 2 cross 2. This is also 2 cross 2. This is also 2 cross 2. If I ask you to find A plus B or A minus B, for that matter, anything, it does not matter. A plus B is what? Find out what is A plus B. So I should write what? This will be 0, 3, 6, 2. Okay, this will be this one. If I ask you to find A minus B, what you should find? If I ask you to find A minus B, please observe all of you this step. If I ask you to find A minus B, you can write it as what? A plus minus B. That means what? Whatever the elements are there for B, you make it multiply with minus, then you add it. That's all. You multiply with minus and then you add it. So A minus B means this will become plus, this will become minus, this will become minus, and this will become plus. Now you add it. That's all. So A minus B, if I ask, A plus of minus B. For matrices in B, whatever the elements are, multiply with minus sign and you add it. That's all. Okay. This is the meaning of A minus B. Clear? Got it, everyone? What is addition of matrix? Now let us take an example. Suppose they give, suppose matrix A is given like this. We have to find that only, no? So suppose matrix A plus B is given like this, minus 3, 2, okay, 4 and 1. A minus B is given as 2, minus 1, 3, and 4. This is given like this. A plus B matrix is this, A minus B matrix is this, then find A and B matrix. Then find how to find A and B matrix. What you will do? So A plus B, A minus B. Add, if you add you will get A, if you subtract you will get B. Try this all of you. Just linear equation. If you get A plus B, A minus B, what you will do? You will solve the linear equation. Same way we have to do here. Okay, try this. What you will get? A and B. You try and tell me. What is the answer? Okay, let me do it. So A plus B, A minus B. So A plus B, if I add it, you will get what? 2 times A will be equal to what? I should add all of this, no? Minus 3 plus 2 is what? Minus 1. 2 minus 1. This is what? 1. This is 7. This will be 5. So if I send 2 here, I will get 1 by 2, or if I send it inside, this will become what? A will be equal to what? Minus 1 by 2, 1 by 2, 7 by 2, 5 by 2. This is A. B, 2B, if I add or subtract it, I will get it as what? Minus 5, 3, 4 minus 3 is 1, minus 3. So B will become, if I send 2 inside, 1 by 2 will become, so this will be minus 5 by 2, 3 by 2, 1 by 2, minus 3 by 2. Okay, this is easy. That doesn't mean that you have to be what? Careless. While doing each element, you should write correctly. If you get one element wrong, everything will be wrong. Okay, so you should be careful. Okay, clear? So this is when it comes to addition. Now very important, we will go to multiplication of a matrix. Okay, leave this. So multiplication of matrix by a constant. So any matrix is given, you have to multiply by a constant. Suppose a matrix A is given to be A, B, C, D, E, F. Okay, D, F, something like this it is given. F, G, H, I. Okay, it is given like this. If they ask you to find, okay, minus A. Minus A means what? Here constant is what? Minus 1. Constant is what? Minus 1. So you have to multiply by constant minus 1. You have to find minus A means you have to find minus 1 into A. Or if they ask you to find K times A. K times I means every element you have to multiply by K. Here every element you have to multiply by minus 1. That is known as multiplication of matrix by constant. The constant can be anything. The constant can be anything. Now directly let us go to what is multiplication of two matrices. Very important. In the beginning itself I told you, for matrix multiplication to happen, what should be there? The number of rows or the number of columns of the first matrix. The number of columns of the first matrix should be equal to number of rows of the second matrix. Okay, so if I write like this, this is if I write it M cross N, here if I write it N cross D, whatever it is. So whatever I get, N and N cancels, whatever the result, the product matrix I get is will be M cross D. So this should be equal to this. Here columns, here rows. So first matrix, if I talk about first matrix, if I talk about second matrix, if I talk about this column should be equal to this rows. Okay, then only we can say matrix multiplication is possible. Then only we can say matrix multiplication is possible. So see, if I tell like this. Is matrix multiplication AB is possible? AB, is it possible? Think correctly, AB is possible. What is the order of this matrix first? What is the order of this matrix? 1 cross 3, 1 into 3. This is what? 3 cross 1. So definitely this and this will be equal. If we cancel, whatever the product will get will be of the order 1 cross 1. 1 cross 1. Okay. Now how to do the multiplication? So this row element you have to multiply with column element. This row element you have to multiply with column element, each of it, and you have to add it. Let us take an example. So let us take some example for multiplication of two matrices. See, wherever multiplication is there, I'll just directly write the answer. Okay, you have to know how to do multiplication. So see here, first see here, suppose A is given like this. A is given to be 1, 2, 3, minus 2, 0, minus 1, 5, 3 and 2. B is given to be 2, 1, 2, 0, 2, 1, 3, 2 and 4. If I ask you to find AB, first of all, is it possible to find AB? M cross N, this is what, 3 cross 3, this is also 3 cross 3, so definitely it is possible. Okay, so always you understand when it comes to matrix multiplication, see what we do in normal real numbers, AB will be equal to BA, will write it, but here it may not be true. See, it is AB, see AB, whatever the value we get may not be equal to BA. I am not telling definitely it is not possible. It is not equal to BA. AB is not equal to BA. We cannot say for certainty it is equal. There in real numbers, what we say? 2 into 3 is what? 3 into 2. We will get the same value in real numbers. But here we cannot say like that. It may come equal sometimes. It may come equals. But definitely we cannot say it will be equal. So we will write it as what? Not equal. May not be equal. May or may not be equal. May or may be equal. Sometimes it may be equal, but most of the times it will not be equal. So you cannot take what? This is equal to this. So we will write it like this. So this is one important thing, and sometimes it will be equal, that case also I will show. So how to do this multiplication if I want to find AB? I will write it here. So observe here, this row and each column I have to do. So 1 into 2 is what? 2, minus 2 into 0 is 0, okay, minus 5 into 3 is what? 15. So 15 plus 2 is what here? 17. So this row, see this row, what is this? I did wrong. Wait, I did column. Okay. So here we should do what? This row and this column, and this row and this column, each column. So see here, this row, 1 into 2 is 2, 2 into 0 is 0, 3 into 3 is 9. So 9 plus 2 is 11. 11 is the element that should come here. Then 1 into 1 is 1, 2 into 2 is 4, 3 into 2 is 6. 6 plus 4 plus 1. So the answer will be what here? 11. Correct na? Then this element, 1 into 2 is 2, 2 into 1 is 2, 3 into 4 is 12. So 12 plus 2 plus 2 is what? 16. So we will get 16 na, see here, 1 into 2, like you can write it, see 1 into 2 is, this is 2, okay, 2 into 1 is, what is it, 2 into 1 is 2, what is this, 3 into 4 is 12, plus 12, you can write it and add it, but directly try to do it, you will save time. So this will become what, 16, correct no? This will become 16. Now go for second row and each column. Second row, minus 2 into, what is this? Minus 2 minus 4, okay, 0 into 0 0, 0 3, minus 1 into 3 is minus 3. So minus 4 minus 3 is minus 7, you should write where? Here. Okay, next this row, minus 2 minus 1, this way you can write it as what? Minus 2, okay, 0 and minus 2. So this will be minus 4, correct na? Minus 4. The next is, instead of writing inside, write it here, directly you can write it, do the calculations outside. Anything wrong? So see here, minus 2, this is what? Minus 4, 0, and it is what? Minus 4. This is what? Minus 8. Minus 8. He won't be coming, he will come at 7:30. I will bring him, you can leave. He is calling only you, not you. Why that affinity towards you? Why affection towards you only? Okay, I have to come and check in the hostel. Oh, anyways. Okay. So this is what? Now third row. First column. This is what? 5 into 2 is 10. This is 0 into, so 3 into 0 is 0, 2 into 3 is 6. So this is what? 16. Correct na? Next, second column, third row, second column, 5 into 1, 5, 3 into 2 is 6, 2 into 2 is 4, 10 plus 5, 15. This will be 15. Now 5 into 2 is 10, 3 into 1 is 3, 2 4s are 8. Okay, this is what? 21. Understood? I am writing directly 21. Clear? Understood? This is how we do matrix multiplication. Clear? But if you do BA, it may come different value. It will definitely come different value. Okay. Here in this case, it will come different value. Clear? Understood everyone? This is known as matrix multiplication. So based on matrix multiplication, we have certain properties. So see here, AB is not equal to BA. Multiplication of two matrices, two properties which you already know, but please make a note for your revision. See, in matrix you have to write down certain things which I am telling. Okay. So AB is not equal to BA, and A into B into C. That is what this matrix multiplication is not commutative. Commutative means AB into B, I cannot write it as B into A. Okay. So this is what A into BC. That is what A into BC, I can write it as what AB into C or ABC. This is fine. A into BC can be written as what AB into C, or you can write it as ABC. You will get the same value. Clear? And next, this is distributive law. A into B, same as real numbers, it will follow A into B plus C. You can write it as what AB plus AC. AB plus AC you can write it. A into B plus C you can write it as what AB plus AC. If AB is equal to 0, that is what null matrix or 0 matrix, where see, if you take any two numbers, if you are getting product 0, either two numbers should be 0, or one of the numbers should be 0. If I am getting 0, I can write as 0 into 2, or 2 into 0, or 0 into 0 should be equal to 0. But here it need not be same. It need not be. Now then either A or B need not be 0. Even if A and B are not 0, we will still get what? 0 matrix. Even if, see, suppose we will take an example. See here, 1 0 0 0. This is 0 1 0 0. If you multiply this matrix, you will get 0 0 0 only. But this is not a null matrix, 0 matrix. This is also not a null matrix, but still you will get 0. Okay, that means what? A and B will be equal to 0, but A may not be equal to 0 and B may not be equal to 0. But still you will get a 0 matrix. But when it comes to real numbers, one of the numbers should be 0. Correct? No? Then only you will get 0. I am talking about multiplication. So that is the meaning of this statement. Understood? AB is equal to 0, then either A or B need not be equal to 0, or simply you can write neither A nor B will be equal to 0. Either A or B need not be equal to 0. If A is equal to AB is equal to AC, then B need not be equal to C if A is not equal to 0. So usually when we talk about real numbers, if you write AB is equal to AC, what we will write? The corresponding lengths. That is, if you talk about isosceles triangle, if you take AB is equal to AC, what we will do? Angle B is equal to angle C we will write, or length B is equal to length C we will write, something like that. But here it is not possible. A we will cancel, write B is equal to C. In matrix it is not holding true here. So if AB is equal to AC, then B need not be equal to C. Then B need not be equal to C. Then B need not be equal to C. That means what? Need not be means it can be, but it need not be every time. Sometimes it may be equal, but need not be means definitely it doesn't hold good true for all the values. For all the situations or all the conditions it is not true. Some conditions it may be true, but most of the conditions it is not true. That's why we will write it like this. In real numbers definitely it will be true for all the conditions. So we will write directly angle B is equal to angle C, but here it is not possible. So that are the differences you should know when it comes to matrix multiplication. Anyone give the remote? I think temperature is high. Then some more properties. You written this, all of you? Okay. Written all of you this one? Okay. This one, A plus B whole square, you will usually write it as what? A square plus B square plus 2AB. Here it is not like that. It should be A square plus B square plus it is AB plus BA. This is what? AB plus BA. Okay, understood Ritika? It should be what? AB plus BA. Understood ma'am? So this should be AB plus BA. Clear? So A square plus B square plus AB plus BA. So here A minus B whole square, it is same thing here also. It is A square plus B square minus AB minus BA. Minus AB minus BA. Clear? Akshay understood, Liharika, Srinidhi. Okay. So here also, see here A power M, A power N, the law of exponents holds good. The law of exponents holds good here. No problem with law of exponents, same as real numbers. A power M into A power N is what? A power M plus N. So A power M to the power of N is what? A power M into N. A power M into N. This is true. Fifth one write down. Write down the fifth one. So a plus b into a minus b. For real numbers, what do we write it? We write it as a square minus b square. But here it is also minus ab plus ba. Minus ab plus ba. Okay, here it is what? A square minus b square minus ab plus ba. Minus ab plus ba. Now understand one thing. Now I will talk about a condition. If AB is equal to BA, special condition, if AB is equal to BA, that is if matrix multiplication is commutative. Usually it is not commutative, that is you cannot write 2 into 3 as 3 into 2 here. Okay, you cannot write like that. If it is commutative, if it is coming equal, AB is giving me the value as 1, BA is giving me the value as 1, or it is giving me the value of minus 2, this is giving the value as minus 2, then we say they are equal. That is the meaning of equality of matrix. Okay, so here AB, whatever we are getting, order is same, here also order is same and corresponding elements are same. That is known as equality of matrix. AB is equal to BA when it is coming. That means wherever AB is there, I can put, or BA is there, I can put AB. Okay, so this will become what? A square plus B square. Instead of AB plus BA, it will become what? 2AB. This will become what? A square plus B square plus 2AB. Same thing here, this will become A square plus B square minus 2AB. And what about this one? This will become what? A square minus B square. A square minus B square. Why? Instead of AB, if I put BA, instead of BA, if I put AB, minus AB plus AB will cancel. So this will become what? A square minus B square. Please make a note. If AB is equal to BA, or if they say matrix multiplication is commutative, they will use this word commutative. That means what? AB is equal to BA. Given that the given matrices are commutative, find the value of A square minus B square, they may ask. That time you should know that it is, if what the statement they are telling is what? AB is equal to BA. Got it? Understood? Next thing is transpose of a matrix. Let us take an example. Let matrix AB given by 4, 7, 3, 7, 8, 10, 3, 10, 9. This is one thing. Let matrix A be given like this. Another, let us take one more example. Let matrix B be given by 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So transpose of a matrix. So suppose matrix, let me take it as matrix L. Okay, it is of order m cross n. Okay, transpose of a matrix means, okay, the rows will become columns and the columns will become rows. Then if you write a matrix of order n cross m, then we call it as transpose of matrix L. That is, we will write it as L power T or L dash, something like that. That is known as transpose of a matrix. The columns will become rows and the rows will become columns. Okay, so the columns will become rows and the rows will become column. Clear? So if I make this, see here, this is A transpose. If I write it, whatever is in these rows should become column. 4, 7, 3. I will write it as what? 4, 7, 3 rows. 7, 8, 10. I should write it as what? In column. 7, 8, 10. 3, 10, 9. I should write it as what? In column. 3, 10, 9. So see here in this matrix, A power T is nothing but, or AT is equal to A. It is coming same. But here you see B transpose if I write it. So this is what? 1, 2, 3. I should write like this. And this will become what? 4, 5, 6. The order may change. That is no problem. Order may change. Okay. If it is not this is not a square matrix. So order is changing here. So whatever is in columns you will write in rows, or what is in rows you will write in columns. That's all. Okay, but see here, a power t is coming equal to a power t is coming equal to a. From here we will go to one more concept, I will tell you. A power, that is a transpose is coming equal to a. Here in this case, a transpose is equal to a. Such a matrix is called as symmetric matrix. Symmetric matrix. Symmetric matrix. Such a matrix is called as what? Symmetric matrix. Such a matrix is called as what? Symmetric matrix. Such a matrix is called as what? Symmetric matrix. Now about transpose, we will learn certain properties. So what is this? A plus B transpose, what is the value? A plus B transpose, what we can write? B plus C. A plus B, where B, C will come? See, A transpose, you can write it as A transpose plus B transpose. A minus B, this is A transpose minus B transpose. See here, A B transpose is B transpose, A transpose. Here it is reverse. A transpose whole transpose is what? A. A B C transpose is what? Reverse you have to write, and you have to write the transpose. C B A transpose transpose. If A is equal to B, then A transpose will also be equal to B transpose. That if A is equal to B, if two matrices are equal, the transposes will also be equal to each other. Okay, that is the thing. Clear? Done? Now look at this. This is the this is the matrix given. I want you to find A transpose. A transpose means what? What I can write this as? This will be 1 2 3, correct na? 4 1 6. This will be minus 7 4 5. This is what we have. A transpose, we got it. Now A transpose, we got it. Now I will ask you to find A minus A transpose. A minus A transpose. A minus A transpose. Now if you see in this, if you observe, okay, if you observe here, forget about this. This is not a square matrix. If it is a square matrix, here in this matrix everything is coming equal. That is fine. But apart from that, if you observe the diagonal elements 4 8 9, here also diagonal elements it is 4 8 9. Okay. Here also if you observe, the diagonal elements are what? 1 1 5. Here it is what? Diagonal elements are what? 1 1 5. In A and also A transpose, diagonal elements will be the same. It will be what? It will never change. Diagonal elements will be the same. So if I write A minus A transpose, so 1 minus 1 is what? 0. 1 minus 1 is what? 0. Corresponding elements. If I subtract 4 minus, what is this? This should be, sorry, 5 minus 5, this should be what? 0. It should be 6. So whenever they say A minus A transpose, what you should write? The diagonal elements, first of all, diagonal elements order should be same. Here the order is what? 3 cross 3. 3 cross 3. Here also it should be 3 cross 3. What I will write it? I will write it directly 0 0 0 when it comes to diagonal elements. When it comes to diagonal elements. If I ask A transpose minus A, what happens to the diagonal elements here? 0 only. See, diagonal elements are same. Same things if you subtract you will get 0 only. Whether it is A minus A transpose or A transpose minus A. So this will become what? 0 0 and 0. Now look at this. So how to get the value of this? How to get the value of this? Forget about this matrix. So see here we are having, this is the diagonal elements. This is the diagonal elements, correct na? These are diagonal elements we are having. Now what will happen? So 4 minus 2 is what? 4 minus 2 is, you have to write here 2. So A minus A transpose means we have to subtract this from this. Corresponding elements. See here, This one and this one are corresponding. What is this? This one and this one are corresponding. This and this are corresponding. Okay, this and this. These are corresponding. Now see here, you have to observe 4 minus 2 is what? 2. Okay, minus 7 minus 3 is what? Minus 7 minus 3. I'll send to middle school or lower primary if you do mistake like this. Minus 7 minus 3 is what? Minus 10. Okay, minus 10. Okay, this is what? 4 minus 6 is what? Minus 2. Minus 2. We got it like this. First you subtract this from this. From lower to upper you subtract and write it like this. Now what will happen to this? This is a mirror. You take it as a mirror. You have to write what? This is 2 means this will be minus 2. This will be minus 2. If this is minus 10 means this will be plus 10. Okay. This will be plus 10. What happens to this? This will be plus 2. That's all. All the elements satisfied. That's all. So let me explain again. So this is what? The diagonal elements will become 0. So if you talk about A minus A transpose, the diagonal elements are same with the matrix A and also A transpose. Diagonal elements are same. Same thing minus same thing will be 0. So diagonal elements I'll write it as 0. Now when I talk about this remaining elements, this 4 minus 2 is what? 4 minus 2. This one corresponding elements. This one and this. So 4 minus 2 is what? 2. So I'll write 2 here. 7 minus 3 is what? Minus 10. So 4 minus 6 is what? Minus 2. So upper elements how to write it? Same thing you write as mirror. This is what? Minus 2. You have to change the sign. See, this is an image. This will become minus 2. This will become plus 10. This will become plus 2. That's all. Okay. Now we will find it for this. So 0, 0, 0 we got. Why? Diagonal elements first thing will be 0. Now same thing you do. 4 minus 2 only you do. But instead of writing here, write it here. Okay. AT minus A means what is this? First you write it here. So transpose is coming later means you have to write it in lower. This is lower compared to A, this is lower. So write it in lower first. Is compared to A, this is upper. So whatever values you get, write it in the upper. So see here, observe carefully. 4 minus 2 means what? 2. Write it here. Minus 7 minus 3 is what? Minus 10. How write it where? Here. Okay. This is 4 minus 6 is what? Minus 2. Minus 2 write it here. Okay. Minus 2 write it here. Okay. This should come here, na? This should come here. It should be minus 2. Now what will happen? This here, this image of this will be minus 2, image of this will be plus 10 and image of this will be plus 2. Okay, image of this will be plus 2. Yeah, understood now? How to write down? A and A transpose. See, diagonal elements will be same. A matrix given and also diagonal elements given. Just a minute. So understood this one? A minus A transpose minus A. So first diagonal elements will be 0. So first you will write what? This minus this and this minus this, and you will write what? Once you write lower elements, upper elements you can write it as along with the change in sign. For this one you should write upper triangular elements. Then lower triangular elements, how you will write it? With the negative sign. That's all. That is called image of that. Clear? Okay. This is when it comes to A minus A transpose minus A. So A minus A transpose or A transpose minus A, they are also called as skew symmetric matrix. Okay, they are also called as what? Skew symmetric matrix. Skew symmetric matrix of the AC, right? This is called as what? Skew symmetric matrix. Clear? They are also called as. ఇక్కడ ఏం కనిపించదు, ఇక్కడే చూడాలి. Okay, words ఉంది. So this is what? A minus A transpose minus A. They are called as what? Skew symmetric matrix. This is also what? Skew symmetric matrix. This is also what? Skew symmetric matrix. I'll discuss about that now. Okay. So if A transpose is equal to A, we call it as what? Symmetric matrix. If A transpose is equal to minus A, that is what? Skew symmetric matrix. And very important property you must know. If they ask determinant of skew symmetric matrix, A minus A transpose or A transpose minus A, the value will be what? What is the value of this? What is the value of this? This will be 0, this will also be 0. Determinant of a skew symmetric matrix is 0. Determinant I will be discussing the next class. Today I am talking about matrix, but here A minus A transpose is what? Skew symmetric matrix. A transpose minus A is what? That is also skew symmetric matrix. Determinant of both of this will be equal to 0. determinant of both of this will be equal to 0. This one you have to know. Determinant of both of this will be equal to 0. Okay. So this one you have to know. Clear with this one? Written all of you? Written? So let us go to the next concept. There we will be discussing what is a symmetric matrix and skew symmetric matrix. Already I have told you. Symmetric matrix is what? A transpose is equal to A. Skew symmetric is what? A transpose is equal to minus A. A transpose is equal to minus A. Bazigar, hi sir, hi Bazigar. Bazigar song you want to sing? So symmetric matrix. Symmetric matrix means if A transpose is equal to A, then we call it as what? Symmetric matrix. Then we call it as what? Symmetric matrix. Okay. So let us take an example for this symmetric matrix. Let us take the same example which we took. 4, 7, 3, 7, 8, 10, 3, 10, 3, 10, 9. Let us take the example, same example. So see here, if I write the transpose of this, this will become what? 4, 7, 3, 7, 8, 10, this will become what? 3, 10, 9. So see here what happens, forget about the diagonal elements, what happens, whatever is the upper triangular matrix is same as the lower triangular matrix. Whatever is the upper triangular matrix is same as the lower triangular matrix. That is known as A is equal to A transpose. That is A transpose, if A transpose is equal to A, then A is what? A is a symmetric matrix. If I write SM, that is symmetric matrix. Okay, that is symmetric matrix. So A we got it like this, A transpose will be like this. Okay, whatever is the upper element, see here, forget about the diagonals, these elements, same thing is coming here. Here whatever is the upper element, same thing is coming here. Where? In symmetric matrix, not skew symmetric. Skew symmetric it will be same value, but the sign will change. Same value in skew symmetric, same value. Suppose I write 7, 3, 10, here also you should write 7, 3, 10, but here it should be minus 7, minus 3, minus 10, when it is skew symmetric. But it is symmetric means same value if you write, no change in sign also. Okay, now suppose I give an example here, see, if I write it like this, A, B, C, D, E, F, G, H, I, okay, G, H, I. Suppose I say this matrix A is symmetric matrix, then what I can say, D is equal to C I can say, so see here, this is the diagonal elements, D is equal to B I can say, right, D is equal to B, G is equal to C and H is equal to F. This is what? When it is a symmetric matrix, then if it is a skew symmetric matrix, what happens? D will be equal to minus C, okay, G will be equal to minus F and H will be equal to, D will be equal to minus B, this will be minus C and minus F. Okay, that's all. Clear na? Understood. And here very important point you have to make a note, that is A plus A transpose. A plus A transpose is a symmetric matrix. Please make a note. A plus A transpose or A transpose plus A. That is what? Symmetric matrix. Focus on the class, not outside. A plus A transpose is what? Symmetric matrix. Okay, that is a symmetric matrix. A plus A transpose is what? It is a symmetric matrix. You got it? A plus A transpose is a symmetric matrix. You have to remember this. A minus A transpose is what? Skew symmetric. A transpose minus A is what? Skew symmetric. So A plus A transpose is a symmetric matrix. Clear? Next one. Understood this one? Written everyone? Write down. This is important. For you to remember, this is important. Clear? So when we talk about symmetric matrix, upper elements will be equal to the lower elements, corresponding elements. But when we talk about skew symmetric matrix, upper elements will be equal, but with a change in sign. That's all. Okay, with a change in sign. Now A plus A transpose is symmetric, and also for a symmetric matrix, A transpose will be equal to A. Next we will talk about skew symmetric. Skew symmetric means A transpose will be equal to minus A. A transpose will be equal to what? Minus A. Okay, A transpose will be equal to what? Minus A. Suppose we will take an example. So A will be equal to, if you take it as 3 minus 5 minus 3 5 minus 7, okay, 0 0 0 and 7. First point is what? In a skew symmetric matrix, all the diagonal elements will be 0. A transpose is equal to minus A, then we say that A is what? A is skew symmetric matrix. So, A is skew symmetric matrix means all the diagonal elements will be equal to 0 and the sum of all the elements of the matrix will be equal to 0, okay, will be equal to 0. There are certain important properties when it comes to skew symmetric matrix, please write down. First thing is what? Sum of elements. Sum of what is it? First of all, first point is what? All the diagonal elements are equal to 0. All the diagonal elements are equal to 0. All the diagonal elements equal to 0. All the diagonal, not sum, just the diagonal elements equal to 0. If you add all of them, that is also equal to 0. Okay. All the diagonal elements are equal to 0. Sum of elements. Sum of all the elements. Sum of all the elements of skew symmetric matrix. Of skew symmetric matrix is equal to 0. Next thing, of skew symmetric matrix is equal to 0. Then, if A is skew symmetric matrix of odd order, then determinant of A, like this, if you write it, will be equal to 0. Then, if you write, if A is skew symmetric matrix of even order, of what? Of even order, then determinant of A will be equal to k square, where k is a perfect square, where k is a perfect square. Determinant of A is what? Equal to k square, where A is a perfect square. Okay, where A is a perfect square. Okay, you want DC? Where A is a perfect square. Where A is a perfect square. Perfect square can be, it can be 0 square also. 0 square. Okay, 0 square means 0 only. 1 square, 4, okay, 9, 16, 25, 36, 49, 64, it goes on like this. Okay, if it is matrix is of even order, 2 cross 2, 4 cross 4, then determinant of that matrix, if A is a skew symmetric matrix, it will definitely be a perfect square. Then in the option, if you are seeing a perfect square, that will be the answer. But if it is of even odd order, determinant of that matrix, skew symmetric matrix, will be equal to 0. And I also already told you this one. A minus A transpose is a skew symmetric matrix, and also A transpose minus A is a skew symmetric matrix. Okay. Then determinant of A minus A transpose or A transpose minus A will be equal to 0 if A is what? A is odd order. Okay, odd order. Now one more thing I can tell you. What is it? If you see the trace of the matrix A will be equal to what? 0. Because all the diagonal elements are what? 0. So seventh one, you should write it as what? Trace of A will be equal to 0. If A is what? Skew symmetric matrix. This I am talking about what? Skew symmetric matrix. Make a note, all of you. So symmetric matrix A transpose will be equal to A. That time, so diagonal elements, you need not worry. Whatever the upper triangular matrix will be same as the lower triangular matrix. But when it comes to skew symmetric matrix, A transpose will be equal to minus A. So diagonal elements will definitely be equal to 0. All the diagonal elements will be 0. Okay. Then upper triangular elements will be equal to lower triangular elements, but with a change in sign. Okay, there will be change in sign. So all the diagonal elements are 0. Sum of all the elements of a skew symmetric matrix is 0. If A is skew symmetric matrix of odd order, determinant of that matrix will be 0. If it is even order, determinant of that matrix will be equal to k square, where it is a perfect square. A minus A transpose is a skew symmetric matrix. A transpose minus A is a skew symmetric matrix. Determinant of A minus A transpose or A transpose minus A, where A is of odd order, will be equal to 0. Trace of A is equal to 0. And I also told you A plus A transpose is what? Symmetric matrix. Okay, A plus A transpose is symmetric matrix. A minus A transpose is Skew symmetric matrix. Okay. Written all of you. And also this matrix A, I think it is here. This matrix A, any square matrix can be written as what? 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose. Please make a note of this also. Please make a note of this also. This is also important. It will be useful in questions. Any matrix A can be written as what? 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose. That is, any matrix can be square matrix can be written as sum of symmetric matrix and skew symmetric matrix. Correct na? Any square matrix can be written as what? Sum of symmetric matrix and skew symmetric matrix. Okay, they can give us statements. If they give like this and they can give reasoning, any matrix, square matrix can be written as what? Sum of symmetric matrix and skew symmetric matrix. Clear? Now we will be talking about very important, that is, there are various types of matrices still, but for your syllabus one more type is there, that is orthogonal matrix. That is what? Orthogonal matrix. Next matrix we are talking about is orthogonal matrix. So what is an orthogonal matrix? So have you heard already? You must have known this is A into A transpose if it is equal to identity matrix, or A transpose into A if it is equal to identity matrix. Then we say A is what? Orthogonal matrix. A we call it as what? Orthogonal matrix. Then A we call it as what? Orthogonal matrix. A matrix and its transpose, multiplication, if it gives you identity matrix. Identity matrix means what? Where the diagonal elements are equal and they are equal to 1. Okay. And if the matrix transpose and its matrix, transpose of a matrix and its matrix product, if it gives you identity matrix, then that matrix A is called as what? Orthogonal matrix. Then that matrix A is called as what? Orthogonal matrix. Okay. Then that matrix A is called orthogonal matrix. Here there are certain important properties which you have to remember and make a note. Okay. Boring? Okay, important. It is important. See, if I am writing, if A is an orthogonal matrix, 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 suppose let us take let A be like this. See, A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay. A1, B1, C1, A2, B2, C2, A3, B3, C3. If A is an orthogonal matrix, first thing you can write it as what? So, sum of squares of this, see, are like this. See, A1 square plus B1 square plus C1 square will be equal to what? 1. The row elements, if you square and add it, each row element will be equal to 1. So, second row, A2 square plus B2 square plus C2 square will be equal to 1. Similarly, A3 square plus B3 square plus C3 square will be equal to 1. Okay, will be equal to what? 1. Will be equal to what? 1. This is about rows. Then what about columns? What about columns? They are also equal to 1. If you talk about column, A1 square plus A2 square, A3 square, that is also equal to 1. So, if I talk about columns here, A1 square plus A2 square plus A3 square, they will also be equal to 1. These properties are important because directly if you see the question orthogonal matrix, if you apply this easily you can solve. If you apply any of this property, one property, you will be able to get the answer very easily. Okay. So, this is not there for a board exam, but here it is useful. There you won't use this, correct now? So, here you see. So, I can write this as what? Second column, B1 square plus B2 square plus B3 square will be equal to what? 1. And what about this? C1 square plus C2 square plus C3 square is equal to what? 1. Is equal to what? 1. Now, this is about what? The column wise and row wise addition. Now, if we talk about these two rows and also these two rows elements, if you multiply and add it, what you will get? The answer will be equal to 0. Now, see here I am talking about see A1 A2 plus B1 B2 plus C1 C2. Similarly, A2 A3 plus B2 B3, C2 C3. Then A1 A3 B1 B3 C1 C3. What about rows is done? What about columns? There also A1, B1, B1, C1, A1, C1. See here, A1, B1, okay, plus A2, B2, plus A3, B3. Next, B1, C1, B2, C2, B3, C3. Understanding how I am writing? Understanding how I am writing? This into this, this into this, this into this. Okay, then this into this into this, and this into this into this. Okay, A1, C1, A2, C2, A3, C3. This is not equal to 1, not equal to 1, not equal to 1, but equal to what? 0. This is 0, 0, 0, 0. See, all the row wise elements if we square and add it, okay, all the column wise elements if we square and add it, that will be equal to 1. But 2 columns, 2 rows, see, first 2 columns, first 2 rows, if you multiply the elements and add it, it will be equal to 0. Second and third row, if you multiply and add it, that will be equal to 0. First and third row, if you multiply and add it, that will be equal to 0. Same thing goes for column. So how many? This one is there, 6 plus 6. So 12. 12 properties are there when it comes to orthogonal. You don't have to by heart also. Just if you remember, you will be able to do it. Okay, you will be able to do it. Just now I will be able to show you one question based on this. There are many questions, one question I will show you now. Just based on this property, you will be able to solve. Clear? Understood? So first we started with what is a matrix. Then we studied what is the order, all these things. Then we studied the types of matrix. First is row, column, null matrix. Then what is a diagonal element, upper triangular element, lower triangular element, diagonal matrix, upper triangular matrix, lower triangular matrix. Then what is square, rectangular, and diagonal matrix, scalar, and identity matrix or unit matrix. Then we studied what is transpose of a matrix, addition of matrix, multiplication of matrices and their properties. And we studied what? Symmetric matrix, trace of a matrix. Yes, sum of the diagonal elements is equal to what we will get, that is trace of a matrix. Then we studied what is symmetric matrix. A transpose is equal to A transpose is equal to minus A is skew symmetric matrix. Then symmetric matrix, A is given and its symmetric matrix, what we will do, diagonal elements we will write it as it is. Upper triangular elements, lower triangular elements will be equal to, they will be equal when it comes to symmetric matrix. But when it comes to skew symmetry, they will be equal with the change in sign, and diagonal elements will be 0. So A minus A transpose minus A, they will be skew symmetric, and A plus A transpose or A transpose plus A will be symmetric matrix. These things we learned, and then we studied orthogonal matrix and then the properties. Now we will do the previous year questions. So see here, if 3A is given like this, A into A transpose is equal to I. They will not mention it is orthogonal. By looking at it, it is what? A into A transpose is I, means it is what? It is orthogonal matrix. Here what did we write? A into A transpose is equal to A, or A transpose into A is I. It is what? A is what? Orthogonal matrix. That is same thing they have given. They will not mention it is orthogonal matrix. If it is given like this, then you have to understand it is orthogonal matrix. They are telling what? If 3A is equal to like this, they are telling find A by B plus B by A. So A by B, here A into A transpose, not 3A. So I should write what first? Excuse me. A I should write it. This will become what? 1 by 3, 2 by 3. We got A, correct now? We got A here. We have to find what is this? A by B plus B by A. So if I take LCM, this will become what? A square plus B square by AB. We can find A and B easily. So if I multiply this column and this column. So this column and this column, if I multiply, what is this? 1 by 3 into 2 by 3 plus what is this? 2 by 3 into 1 by 3. Okay, plus A by 3 into 2 by 3. This is equal to what? 0. So what is common here? 2 by 3, 2 by 3, 2 by 3 is common. I can remove it. It is 0. So this is what? A by 3. So A 1 by 3 plus 1 by 3 is what? 2 by 3 plus A by 3 is equal to 0. So A by 3 will be equal to what? Minus 2 by 3. So 3 cancels. I will get A is equal to minus 2. I got it. Similarly, let us find B. To find B, what we will do? We will multiply second and third column. Very simple. Orthogonal. Okay, otherwise it will be difficult for you to solve. You can find it using various other ways. You can take A into A transpose is equal to I. What you will do? You will write matrix A, you will write matrix A transpose, and you will write it as I. That is what? 1, 1, 1, 0, 0, 0, 0, 0. You will multiply, then you will get the answer. That will take a lot of time. We don't have that much time. So here what I can do? This one and this one. This one, what is this? Second column and third column. If I multiply, what is this? 2 by 3. No, don't multiply directly. Keep it like this. 2 by 3, 2 by 3. Plus, what is this? 1 by 3 into minus 2 by 3. Plus 2 by 3 into b by 3 is equal to what? 0. Again what I can do? 2 by 3. 2 by 3 I can cancel. Again 2 by 3 I can cancel. So I am having 2 by 3. Here it is, minus will come here. Minus will come here. I can shift minus here. So 2 by 3 minus 1 by 3 is what? 1 by 3. So b by 3 plus 1 by 3. b by 3 plus 1 by 3 is what? 0. Okay. b by 3 will be equal to minus 1 by 3. 3 3 cancel. b will be equal to minus 1. Now put the value here. A is what? A is minus 2. B is minus 1. So minus 2 square plus minus 1 square. This is what? Minus 2 into minus 1 is 2. So this is what? 5 by 2. The answer is 4. 5 by 2. That is option 4. Understood na? Very simple. Orthogonal properties. If you use, you will get it easily. So that's why matrix you practice well. Because matrix questions easy to solve. 3-4 questions easily you can score. Matrices and determinants. Okay. Got it? Compared to integration, all these things, this is very simple. Correct na? Okay. Got it. Next question, shall we go? 7:30. Okay. Answer this question. Please answer this question. Zero. Very simple, no? 0. So if you don't know what you will do, you will put the values and you will find out. So this is what A is given. Then determinant is A minus A transpose. I told the property. That is what? Is equal to 0 directly. They have asked directly. 2024 they have asked directly such easy questions. You shouldn't leave. Such easy questions will also come. That's why you have to go through all the questions. Okay? Clear? Look at this. If A is equal to, they have given, if A is equal to this one, A transpose, A into A transpose minus A square is equal to what? A into A transpose minus A square is equal to what? How to do this here? A into A transpose minus what is this? A square I can write as A. A into A. A I can take common. A into, I can take it as what? A transpose minus A. A transpose minus A, we will write it. So A transpose minus A. A transpose minus A, if you write it, definitely we know that diagonal elements will be 0. So diagonal elements will be 0. I will write it as what? Like this. So let A be here. Okay. A transpose minus A, I am writing the value. The diagonal elements will be 0, 0, 0. So this will be what? 1 minus, what is this? 1 minus 3 is what? Minus 2. This is what? 7 minus 8 is what? 7 minus 0 it should be. Correct na? 7 minus 0. 7 minus 0 is what? 7. Correct na? 7 minus 0. 6 minus 8 is what? Minus 2. So this will become what? I should write it as what? 2 minus 7 should come here. Minus 7. This will be what? Minus 2. This will be what? 2. A transpose minus A. This is what? Skew symmetric matrix. A transpose minus A, it is skew symmetric matrix. So this will be how to write it in reverse sign. Okay. Now you have this. Now what we have to do? A is given. So write the value. Write what is A. That is what? 930. Okay. 158. 762. This is A. A into what is this? A transpose minus A. 0, 0, 0. 2 minus 7. Okay. Minus 2. 2. This is what? 7 minus 2. Now you multiply it. They are asking what? Summation of A of ij. I is like greater than 1, greater than or equal to 1, less than or equal to 3. J is greater than or equal to 1, less than or equal to 3. That means what? You have to add everything. All the elements. Summation of A of ij. That is what? I can be what? 1. I can be 3. I can be 2. J can be what? 1. J can be 2. J can be 3. So that means what? All the elements you have to add it. So once you multiply whatever the value you get, you have to add it. So multiply this. What we will get? Let me write down directly. don't have much time, let us write the, I'll do it, don't worry, I'll do it. So if you multiply this, what we will get? So on multiplying this, we will get it as the value as 6 minus 18, 57 minus 46, okay, 14 minus 3, okay, minus 2. I hope you are aware of matrix multiplication, directly I am writing it. So we will get it like this. Okay. Now we have to add all the elements. First you add column wise or row wise, anything is fine. If you add column wise, see here 6 minus 46 minus 2. So this will become what? Minus 42. Minus 48 plus 6 is what? Minus 42. So minus 28 minus 14 is minus 14. Okay. So 57. 50 plus 30 is 80. 80 plus 7 plus 7 is what? So 94. 94 minus 3 is what? 91. Okay. 91. So minus 56 plus 91. Minus 56 plus 91. What we are getting? The value? 35. 35 will get, that is the answer. 35 will be the answer. Like this you have to find the sum. Okay. Alright. This is the way we have to find. So in the next class what we will be doing? We will be solving some more questions, okay, of matrices. Still we have to discuss about what is inverse. There we have to discuss about what is adjoint of a matrix, cofactor, minor, all these things. Clear? So for today's class we will end it to now, and tomorrow we will be discussing more about the matrices and also about determinants. Thank you.